Pre-AP Calculus, Notes 8.3. We are going to be focusing in this first video on using the log identities 1 and 2. Log identity 1 says that if you have a base and your exponent is a logarithm that has the same base, this entire thing becomes the argument of the exponent. This one down here is going to be the same. We have a base raised to a logarithm with the same base. This becomes the argument. Same here. We have a logarithm with a base of 4. I'm sorry, this is the second log identity. Actually, that was the second log identity that we just did. This is the first log identity here. I said that backwards. Same results though. If you have a logarithm with a base and your argument has the same base, this just becomes the exponent of the argument. Log base 5 of 5 to the 3 over 2. Your logarithm has a base of 5 and the argument has the same base of 5, so this just becomes the exponent of the argument. These last four, this is natural log, which means it has a base of e. Argument has the same base, so this becomes the exponent of the argument. Same is true with this one. Natural log of e to the 0.005 has a base of e for the log. Argument has a base of e, so this just becomes the exponent of 5 thousandths. Thousandths. Last one, last two, e raised to an exponent. The exponent is a logarithm that has the same base. Natural log has the same base of e. This just becomes the argument of the exponent. Same thing with this last one. So this is log ID number 1, these 4, and this is log ID number 2, these 4. You don't have to know them by log ID 1 and 2. Those 1 and 2s are arbitrary, but for references to our notes, that's what those are. Use properties of exponential and logarithmic expressions. Using the properties of exponential and logarithmic expressions, simplify each expression below. Well, this first one, we have a base of e for the logarithm, and our argument has the same base, so this just becomes the exponent of the argument. This next one, this radical here is not great, this cubed root, so we could change this to natural log of e to the 2/3. Natural log has a base of e, the argument has a base of e, so this just becomes the exponent. Now this next one's a little tricky because this has a base of 10, the exponent's logarithm has a base of 10, so you think, well, maybe the answer is just x, but it isn't. In order to use the log identities, we can't have any coefficients. So this exponent has a coefficient of 2. So just focusing on this right here, if this was the entire problem, hopefully you remember it, we can take the coefficient and write it as an exponent. So that means this would become 10 to the common log of x squared. So this is an exponent for 10, and this is an exponent for the x. Now, using the log identity, we have a base of 10, which is raised to an exponent that is a logarithm with the same base of 10, so it just becomes the argument. Very similar, this next one, e to the 2 times natural log of x plus 1. We can't use the log identity while that 2 is there. We can write the 2 as an exponent for the argument. And then using the log identity, we can make this simply the argument. We can do that because the base and the exponent has the logarithm with the same base. We can set it equal to the argument. This next one is straight up same property. We don't need to move anything around, so it just becomes the argument. Now this one here is a little tricky. This doesn't just become x. It's important to note that the argument is not x plus 2. If it was, it'd be in parentheses. This is natural log of x, plus a 2. If we can break this down and make this natural log of x times e squared, I think I misspoke, e to the natural log of x times e squared. How can I do that? That is a property of exponents. If you are multiplying with the same base, you add the exponents, which stands to reason if you're adding exponents, you can rewrite it as the same base multiple times, and then whatever you were adding, one of those is one of the exponents and one of them is the other one. So typically we had something like x squared times x to the 5th. We would say that's x to the 2 plus 5. We're just doing this backwards. It's already added and we're breaking it apart. Now this becomes x because the identity, we have a base of e and its natural log with a base of e becomes the argument. And the e squared, there's nothing we can do with that. E squared is a number. Typically we put the numbers in front and the variables in the back, but you won't have to rewrite it. This next one let's do in a very similar way because the exponent has addition. This is the same as 5 squared times 5 to the log base 5 of x. 5 squared is 25. Using the same log idea we've used many times today, this just becomes x. Our base is 5 and our exponent is a logarithm with also a base of 5, so it becomes the argument, which is just 25x. Don't have to write 25 times x. You could write 25x. Last one of this type. Common log, base of 10, this just becomes the exponent. Natural log, this argument is the base e, this just becomes the exponent. Nothing else we could simplify with that. That concludes the first video, which is basically really focusing on the log identities 1 and 2. You never know when you're going to need them, but when you can use them, you really should use them. I believe we're going to have maybe 3 more videos in this section.